Hi, welcome back. In this video, we are continuing to look at graphing square root functions. In this video, we are actually going to look at the transformed function. So if our parent function is f of x is equal to the square root of x, our transformed function, if we go back to what our general function notation is, our transformed function g of x is a times f of x minus h plus k. We can remember what each of these things do because they do pretty consistent things. A is a vertical stretch or shrink. It's also a vertical reflection. So if A is bigger than 1, this graph is going to get taller. If A is less than 1, this graph is going to get shorter. If A is negative, this graph is going to flip and reflect itself over the x-axis. H is a horizontal shift, and you should note that this is x minus h, so it's going to be the opposite sign of whatever is written there. So this is going to shift the whole graph back and forth, left and right. And K is our vertical shift, so this is going to shift the graph up and down. And I want you to note that this is plus K, so it is the same sign. So let's take a look at a general transformed function. So this is g of x is equal to a times the square root of x minus h plus k. Just like with our parent function, we are going to start with the domain because we have really important domain restrictions going on. So the most important thing we have going on is that whatever is underneath the square root must be greater than or equal to 0. So this ends up giving me x must be greater than or equal to h, or my domain is from h to positive infinity. So that means I'll take h and I will plug it in as an x value, and I get a times the square root of h minus h plus k. So h minus h is 0. The square root, so this becomes a times 0 plus k. This is 0, so this just ends up being k. So my vertex is at hk. Remember, this end point of my domain relates to my vertex. So I'm going to have some vertex at hk. I don't know where it is. This is just a point I have chosen. So now the next thing I need to do is I need to be thinking about what effect A is going to have on this. So if A is positive, my graph will look something like this. So this would be if A is positive. So if I have a positive A, it might be a vertical stretch or shrink, meaning it could be flatter. That would be a smaller A. It could be taller. That would be a larger A. So this would be a small A. This would be a big A. But if A is bigger than 0, it's going to look like this, which means my range will start at K and go to positive infinity. So this is if A is bigger than 0. If A is less than 0, my graph is going to look something like this. So if A is less than 0, my graph is going to be mirrored and it's going to open down. Again, it could be smaller, it could be shorter or flatter or taller. So this would be a big A, like say -2, -3. This would be a small a, like say 1/2. But if it is negative, it is going to flip it over the x-axis. So it will open down. In this case, my range will be from negative infinity up to k. So I need to keep this in mind, and you may consider graphing this. When you're working with your table, choose nice values. Choose values that you're going to be able to take the square root of. Remember, I like to be able to take the square root of 4 because it's 2. The square root of 9 is 3. The square root of 16 is 4. Choose values that are nice like this. You could even choose something that is like the square root of 9/4 because that is 3/2. I can do things like that. I'm probably not going to want to take the square root of 7 because that's not really something that I readily know So I'm probably not going to make 7 something that I plug in here, but I want to think things through. Don't plug in x equals 1, plug in the x value that will make this equal to 1. So be thinking through what value of x will make the radicand, the part underneath the square root, equal to a nice value. For my intercepts, for the x-intercept, just like before, we plug in y equals 0. And for our y-intercept, we plug in x equals 0. And you'll just plug those in and solve. When we're looking at our end behavior, as x approaches positive infinity, y will approach positive infinity if a is positive, and y will approach negative infinity if a is negative. As x approaches h from the right, so now I'm not approaching 0, I'm approaching h. I'm approaching the edge of my domain restriction. So as my x values are moving from the right to the left, and I'm getting closer and closer and closer to h, my y value is going to get closer and closer to k, regardless of what a is. So this is kind of my framework for a transformed function. In the next video, we're going to take this framework and apply it to some examples.